Hey guys, welcome to another engineering video tutorial. So in this video, we're going to be starting at the beginning and discussing engineering fundamentals. So in this class, you'll be going over the design process, the principles of engineering, and what to do in order to pursue a career in engineering. So this first week, we will be going over some of the basics, which are found in chapter 1 of this book. You won't actually have the book, but I'll be giving you all of the information from the book via video, and we'll be just going over, what exactly is engineering. So our objectives for this week, and they're bullet point by exactly what we will be going over each day. So today we're going to be just making sure that we define engineering and exactly what engineering is and how it's used in the world. We're going to identify and describe the types of knowledge that are used by engineers on tomorrow. On Wednesday, we'll be listing the roles that make up an engineering team. On Thursday, we'll be going over the different engineering disciplines. And as I said on the first day, that some of our projects that we'll be doing, especially once we become face to face again, will be based on showing you how to manipulate and do things, whether in the 3D modeling software or with like our Bex robotic kits or some of the physical kits that I have in my classroom that go over, how electrical engineers work, how civil engineers work, mechanical engineers, and so on. And then on Friday, we're just going to summarize some of the historical developments that have occurred in the world because of engineers. So, engineers use math, science, and technology to create products and systems to improve the world. So that's the basic definition. So when you're trying to understand that everything that you want to do in engineering, you have to have a foundation in math and science. For many of you that are in the physics class, you're going to realize that a lot of what we do, whether it's hands-on or not, it's going to look like your physics class. Even some of the projects that we did last year, some of the students said, "Oh, I remember doing this. We also did this project in my physics class." So that's how math and science come together. One of the differences between math and science and just engineering as a whole is that as an engineer, you're using that knowledge to create technology to push the world forward. So, math is just the theory, calculations. Science has the scientific theory, understanding how things work. We put that together to basically make products to make money. So engineers we're in the STEM category, but we're in the STEM category for making ourselves and companies money. And we would like it to improve the world. Sometimes things that improve the world can also hurt the world. We'll be going over green energy later, but because of transportation and everything, we're able to do a lot more that people were able to do long time ago in history, as far as travel and the things we can accomplish. But we're also damaging the world, through pollutants. So even when we're trying to improve the world and trying to improve society, we have to be cognizant of the environmental impact that we are having on the world as engineers. So engineers are highly trained professionals. So when I say highly trained professionals, even on the basic foundation of it, when everybody else talks about going to a 4-year college, you're talking about going to a 5-year college. So most engineers take 5 years to get their undergraduate degree. So if you're class of 2021 and you're going to school for engineering, you'll probably be walking the stage with people who graduated class of 2022 from high school. That's just the nature of our industry. We have more courses to take. We also have to spread them out more than other people do in a lot of other majors, because our courses can be, very hard, very complicated, very strenuous. So we end up spacing them out so you don't end up being overloaded with a bunch of engineering courses at the same time. If you think about it in high school's terms, imagine going to class and having, I think y'all take 7 classes a day. So imagine having 3 science classes and 3 math classes and then an elective. And that's what your day looks like if you try to take all your engineering classes at the same time. And all engineering classes are pretty much AP courses. So you want to be able to spread that out. We'll talk more about preparing for college once we get back into the classroom. Even once you get your degree, they're expecting for you to have some kind of training. So as I said on my About Me, Schlumberger also paid me in undergrad to be an intern. So I know, if you ever heard of internships, a lot of people say, you can be an intern, work for free, learn some skills. I was getting paid, I think at the time it was like $18 to $20 an hour to go to work and work with engineers. And I was actually solving problems. So the software that I said that we're using in the Engineering Design and Presentation 2 course, I actually was using that for a guy that was an actual engineer. He was my manager. I was designing tools for his test fixture that he went on to get patented for the company while I was back at college. The other thing is you can get certified. So especially in civil engineering, you can become what's called a professional engineer. And that's where you go and take a test that proves that you've not only worked in industry for like 5 years after getting your degree, but you go and pass another test that shows that you are highly trained. And with that, you get to make money for consulting. And that's even more money. So other people will do a whole bunch of work and they'll pay you to look over their drawings and everything. And because you have that professional engineer's license, you can put your stamp of approval and they'll pay you to be able to put that stamp of approval on it. Like I said, with the solving problems using your knowledge and skills, the project that I was working on, my first internship that got patented, whenever, like I told you, I was working on the tractor projects. So whenever you're digging, just like when you're digging a hole in your yard, you see like dirt falls back in. So the well would get real dirty. So I worked with my manager and we developed a chemical and a set of nozzles that would be able to go down in there, and the nozzle would get to the bottom. We turn it on, it would pump the chemicals, and that would bring all of that, all of the dirt, the stuff that we didn't want in the well, back up to surface to clean up the well, so we wouldn't have a problem with our tools going down hole. Because the more junk, and not just dirt, but some of the other basically gook and stuff that's in the well from some of the other tools that we were using, we had to wash all of it out so it wouldn't damage what we were trying to bring. So when it comes to problem solving, we use the engineering design process that we'll go over later, but it's a series of steps that get you to think about your problem, identifying your problem, researching solutions, testing those solutions, and reiterating until you have a good product. The specifications are basically what is it that you want this product to be able to do. So if you think about your camera, the engineers that designed your phone, at some point they wanted to say, okay, we need a 12 megapixel camera. So that's a specification. So that's, the specifications are often the things that you all brag about. Yeah, I got a 12 megapixel camera on the back of my phone. But then the constraints come into play if you think about it, like with the iPhone, You know, there was a point where, you know, cameras were huge. 12 megapixel camera meant you had this huge lens camera. But, you know, as we got technology improved and things got smaller and smaller, now it'll be a specification that's saying, okay, we got a 12 megapixel camera, but you have to fit that camera lens within this 5x5 millimeter space. That's all you have for your phone to be able to get this camera in there. So that's where the engineers have to figure out how they're actually going to get that camera lens in there correctly and efficiently. Constraints are also, you know, money constraints. If you're trying to say that we're going to improve this technology, but we need to keep the iPhone under $1,000, that becomes a financial constraint because every single component becomes an add-on. So then you're also telling the engineers that are part of the camera team, look, whatever you design for this camera, it needs to cost less than $20 or, you know, whatever. Optimization comes with you're always trying to improve it. And then the trade-offs. Trade-offs come all the way along the line, right? So you might be able to get the camera for $20, but if you were willing to spend $40 on our portion of the camera on this phone, we could get this, but I might need this kind of size. So that's when you start deciding what's more important, the money, the space, or the camera quality. And no matter what you're trying to build, you will always have trade-offs because those were, you know, quality, space, money are problems that you're going to have no matter what the engineering project calls for. So now we reached the end of what we're going to be going over today. So you need to go into Schoology, answer the discussion question related to this assignment, and I will see you on tomorrow.